For the next example, we would like to design and write a recursive method that tests whether a string is a palindrome or not. So what is a palindrome string? It is a string that you can read it the same forward and backward, such as radar. So if you compare the characters of the string radar, then as you can see that the first character is R and the last character is also R. And the second character is A, and also the character that just before the last character is also equal to A. So what we want to do, we want to write a recursive method that is called isPalindrome that has one parameter of type string and returns true if the argument is a palindrome and false otherwise. So if the input parameter to this method is this string, which is radar, then the method should return true. So how to process the string to test whether the string is a palindrome or not? You know that the first character is at index 0 and the last character is at index the length of the string minus 1. And we are going to say length minus 1 for short. So in the beginning we compare the character at index 0 with the character that is at index length minus 1. So we are comparing the first character with the last character of the string. If they are not equal, then we stop the process and return false, indicating that the string is not a palindrome. Otherwise, we have to continue and check for the neighbor characters. And to check for the neighbor characters, you break the string into a smaller substring. This substring starts from 1, which is the next character after the first character, and ends at length minus 1, which is the character just before the last character. And again, you have to repeat the same process. You compare the first character of this substring with the last character inside this substring. If they are not equal, you stop the process and return false, indicating that the string is not palindrome. Otherwise, you need to find a substring of this substring. And again, starts from 1 and ends at length minus 1. You keep repeating this until there are no more characters to compare, and the method will return true, indicating that the string is a palindrome. But to follow this process, we need to emphasize on two remarks. The first remark is that whenever we call the method substring on any string, this method returns a new string. Therefore, when we break the string into a substring that starts at index 1 and ends at index length minus 1, then the first character inside this substring is at index 0, not at index 1. And also the last character is at index length minus 1, not at index length minus 2. Therefore, when we call the method recursively on this substring becomes the string in the next call. And again, the method is going to compare the first character at index 0 with the last character at index length minus 1. And this process continues until there are no more substrings and the process is stopped. The second point that we want to emphasize is when to stop the process. We stop the process whenever we call the method recursively on a substring that has size less than 2. Because if we have a substring of size 1, then it has only one character, and this character is the same if it is the first or last character, and the method should return true as a result. So therefore, when we call the method recursively, we are going to test for the size of the string. If its length is less than 2, then we are going to stop the recursive call and returns true. Otherwise, we call the method recursively on a substring that it starts at 1 and ends at length minus 1. Let us have a look into the code on how we are going to implement it in Java. The method is designed to return a Boolean value. If the input parameter str as a string is a palindrome, then it returns true, otherwise it returns false. The implementation of the recursive method is implemented by branching using multi-branch if statement. In the first condition, we test for the stopping condition or the base case. If the input parameter string str has length less than 2, then it has only one character and therefore it is palindrome and the method returns true. In the second condition, we test for the first character and the last character of the input parameter str. If they are not equal, then the process should be stopped and the method returns false, indicating that the input parameter str is not a palindrome. Otherwise, the method is called recursively on a substring that starts at 1 and ends at length -1. But notice that every time we call the method recursively, we are passing a new string to the method. Why? Because the substring method generates a new string. And this makes the implementation of the method not so efficient because it allocates a space for every recursive call, and this allocation is considered a waste of memory. So if we want to improve the efficiency of this algorithm, we're not going to pass a substring of the string for every recursive call. However, we are going to pass the array itself in addition to two other integer parameters that represents the start and end indices of this substring. This way makes the algorithm more efficient because we are processing the array in line using these two variables. And this is how the algorithm is going to work. We are going to have two integer variables. One is called s, which is short for start, and the other one is called e, which is short for end. Initially, when we call the method, the value of s is equal to 0, which is the index for the first character, and the value of e is equal to 4, which is the index of the last character in the string. In the next recursive call, the value of s should be moved advanced by one value, and the value of e should be moved backward also by one value. So in the next iteration, the values that we need to pass for the method is that for the value of s is going to be equal to 1, and the value of e is equal to 3. And in the next recursive call, the value of s and e both will be equal to 2, and the process will stop because the string has a single character. Notice that if the length of the string is odd, then eventually the value of s will be equal to e. But if the length of the string is even, then the value of s will be greater than or equal to end. So therefore, to combine these two conditions, the process will stop whenever the value of s is greater than or equal to e. So here is the implementation. If we want to add start and end two integer parameters for the algorithm that represents the start index and end index for any substring when we call this method recursively, and again inside we have branching. For the first condition in the branching, we check for start. If it is greater than or equal to end, then we need to stop because we have reached the end of the process and the string is a palindrome. Otherwise, we need to check the character that is at index start with the character that is at index end. If they are not equal, then the method returns false, assuming that the input parameter str is not palindrome. Otherwise, we call the method recursively by passing the same array as input parameter, but the value of start should be incremented by 1, and the value of end should be decremented by 1 for the new substring. And this process continues until the value of start is greater than or equal to the value of end. But there is one little issue about the new definition for the recursive method, because we have added two integer parameters and the method should accept only the array as input parameter. To correct this issue or to solve this problem, we can define the recursive method as a helper method and call it from the method that accepts only the array as input parameter.